So, in this session under statistical process control, this is the second part of statistical process control that we are going to discuss. We have 5 lecture sessions. The first lecture will be on control charts for the variables, types of control charts. Specifically, I will be discussing R and X bar chart. In the next lecture, I will discuss the problems on the control charts and the control chart patterns. Third lecture, there are many special control charts for variables, and with examples I will discuss. And in the subsequent lecture, lecture 4, then I will continue discussing special control charts for the variables with examples. And in the last lecture session, multivariate control charts will be discussed with examples. So, this is our plan as far as the second part of the statistical process control is concerned. Okay. Now, let us first discuss the subtopic in this particular lecture session, that is the control charts for the variables, and particularly the two important control charts I am going to discuss. The first one is the R chart and the second one is the X bar chart. Okay, so let me first discuss some important aspects related to quality characteristics which are of variable type. We have already mentioned that there are two types of the data you come across in quality control exercises, in quality control related problems. So, the two types of data are referred to as attributes data and the variables data. We have already discussed attributes control charts, and now we are referring to the variables control charts. Now, what is a variable type quality characteristic? Now, these quality characteristics are such that they can be measured, for which measuring instruments are to be used. Is it okay? Certain times, we also can use certain gauges, but essentially, these characteristics are such that it can be measured. The variables control charts are constructed for such quality characteristics. Okay, so this is its domain. There are many types of the control charts under this category. Some are referred to as the general purpose control charts and some are referred to as the special purpose control charts. Now, what you need to do, that means for each quality characteristics, you need to develop a separate control chart. So, this point is to be noted. Suppose in a given situation, you are dealing with some, say, 20 such quality characteristics which are of variables type, and you have decided that you will go for control charting, okay, for these quality characteristics. So, what you need to do, that means for each one of them, you have to construct a separate control chart. Is it okay? So, this point is to be noted. It is not like attributes control charts, right. So, attributes control charts refer to the proportion non-conforming or the number of non-conformities, okay, demerits per unit, etc., etc. So, those aspects are not related to a particular type of quality characteristic. Getting my point? So, here that means you should be ready with your approach for constructing a control chart for a specific variable quality characteristics. And usually in manufacturing situations, when you deal with many kinds of parts, components, okay, so obviously we will be dealing with various types of the quality characteristics which are of the variables type. So obviously it may not be necessary or may not be possible to construct control chart or recommend control chart for each of the quality characteristics. So what you need to do, out of many quality characteristics initially you come across, you have to select a few which are considered to be very important or critical. Is it okay? So this is the point to be noted. Now that means we'll be dealing with a few non-trivial or important quality characteristics. What are the examples of say variable quality characteristic? There are many examples, like the shaft diameters, like say the thickness, resistivity, weight of an object, etc. That means if you look at all these characteristics, what you find that they are measurable. Is it okay? Now what are the types of control charts for variables you come across? Now these control charts are grouped under two categories. The first one is the general purpose. Now what do you mean by general purpose? That means these charts can be used for any kinds of manufacturing or service related processes or the situations. That means those are general, and as you know that by using a control chart you try to achieve certain objectives. Now if you use such general purpose control charts, that means there are certain general objectives which you need to achieve through control charting, and these general objectives are relevant for any kinds of manufacturing situations. Okay, so that's why and related to these general kinds of the situations and related to the process control aspect, there are some general problems you have to address. So this type of control charts are suitable for addressing those problems, obviously related to the process control. Now you have the special purpose control charts. That means there are certain specific objective, okay, you have to achieve specific objective related to a particular situation. So these are basically situation specific, and there are many special purpose control charts the researchers as well as the practitioners have already developed. So what are the special purpose control charts? That means these charts can be used only as per the requirements of a specific condition or the situation in manufacturing or service organization with a specific purpose. It's clear. Like say in a typical situation where the process is very sophisticated, and the slight deviation of the process parameter value may not be acceptable to you. Okay, so this is a very specific situation, and what actually you need to recommend a special purpose control chart. Okay, now at this point in time I will just note down that there are two specific objectives of control charting. The first objective, as I have already told you, that the first objective is that at any point in time you must be able to conclude whether the process is in control or out of control. So this is the first purpose. That means the first purpose is to ascertain or to conclude whether the process is in control or not. Is it okay? In an online the control system looked at as an online and the real data or the real time control system. Okay. Now the second purpose is very important. The second purpose is if there is any shift in the process parameter value. Is it okay? Now obviously if there is a shift, you conclude that the process has gone out of control. Whether your control chart is able to detect this shift or not as quickly as possible. So the first one is identification of the state of the system, in control or out of control. The second one is ability to detect the shift in the process parameter value. Now many time, what you do, you recommend the special purpose control chart so that the second objective is fulfilled. Is it okay? So these are the two categories. Now let me the focus on say in this particular lecture session, first general purpose control charts. And if you go through the textbooks, if you go through the practitioners the manuals related to quality control, what you find that essentially there are the 5 types of control charts recommended under general purpose category. So what are those? The first one is the R control chart. So the R control chart, if you use the basic purpose of using an R control chart is to control the variability as measured by the range. Is it okay? That's why R stands for the range. So this is also referred to as the range control chart. And along with the range control chart, what you need to do, that means you must use or you must construct and use X bar control chart. So what is X bar? X bar actually it is referred to as the mean. It's a general notation, and X is a random variable and X is a variable, that means a measurable quality characteristic. Is it okay? So X is a value. Okay, so X bar control chart, X bar means the mean of a sample. So this the two control charts you use under general purpose category. The second one is whenever you find that there are situations, I will discuss that situation also. Like in many cases, in certain cases, the sample size may be 1. That means it is essentially the individual the individual units forming the sample. So in that case, obviously the range you cannot calculate. So you have to think of some alternative means, and this one such alternate the means is moving range. That means what you need to do, that means you define or you calculate the dispersions or the variability with moving range. So we'll explain it what is a moving range. So the moving range control chart you have to use, and along with the moving range control chart, what you need to do, that means X control chart for the individual units, that also you need to use. So these two charts we'll be discussing. And the last one I have mentioned, that is S control chart as an alternative to R control chart. S stands for the standard deviation control chart. Is it okay? Now, as I have already pointed out, that if you measure dispersion with range, now it's not that accurate. So what and as soon as suppose the value of n, that means the sample size is greater than 10. Now you may conclude that the range cannot be a good measure for dispersions. Okay, it may be it is an inaccurate measure if n or the sample size is greater than 10, right? Now, so what do? Obviously, say you opt for such cases the standard deviation control chart. So this is point number 1 to be noted. Another point, you must agree that when we started constructing the control chart, particularly the variables control charts, and you may be knowing that this is the top point to be noted, that the variables control chart, any variable control chart is to be used at the operations level, at the process level. That means with the responsibility of developing this control chart rests with the workers or the operators dealing with a particular process for which control chart is recommended. Is it okay? For process control. So obviously, some 50 years back, 60 years back, the workers were not that qualified, very educationally qualified. So it used to be very difficult to ask them. It is impossible for many cases to compute the standard deviation for each sample. So what you try to do, you search for, okay, as a supervisors, as a manager, the line manager, what you say that, okay, I am restricting the number of say sample size to less than equals to 10, within 10, and you have to just the measure or calculate the range. That means you just identify that the maximum value and the minimum value and take its the difference, and the difference is basically the range. Now today what you find that that the process has become so sophisticated and it's technology intensive that these many such processes are essentially run by educated workforce. So obviously if you have these sort of conditions in today's workplace, so why don't you say recommend the standard deviation, say the control chart, instead of recommending our control chart? Is it okay? So so in this discussion what we'll discuss, the standard deviation control chart as such will not be discussing today. Later on we can refer to this, but the basic norms, the basic approach remains same. Only thing is you are measuring the variability or the dispersions not by range but by standard deviation. Is it okay? So what we'll be discussing now, like say we'll be discussing R control chart along with the X bar control chart. Is it okay? And later on I will highlight the specific points, okay, as far as control charting is concerned with respect to the MR control chart and X control chart. Okay. Now what are these special purpose control charts? Okay, so there are many in fact. So but just the important one I have mentioned over here, you can just note it down. Like say the Q-sum control chart. Q-sum stands for cumulative summation control chart. Second one is the trend control chart, or sometimes referred to as the regression control chart. Then we have a class of control charts known as the modified control chart along with the acceptance control charts. Why I have written together? Because if you use modified control chart, obviously you have to use acceptance control charts. That means these two control charts must be used simultaneously. Then we have the moving average and the geometric moving average control charts. Is it okay? Geometric or exponentially weighted moving average control chart also you can use, and the last one is the multivariate control charts. There are many varieties, so the important varieties we will be discussing later on. Okay. Now so what do you try to do? That means selection of the characteristics for investigation. So this is very, very important. In small organizations as well as in the large ones, many possible product and process quality characteristics exist. Okay. A single component usually has several quality characteristics such as length, width, height, surface finish, and say elasticity. Okay. So this is just I am citing some examples. It is normally not feasible to maintain a control chart for each possible variable. I have already pointed out. I have already mentioned this point. So it's just not possible to maintain a control chart, and it's not necessary also. Okay, to maintain a control chart for each possible quality characteristics. So what you need to do, you have to select quality characteristics. You have to be very, very selective for which control charts will be maintained, and this requires giving higher priority to those that cause more non-conforming items and that increase costs. Is it okay? So I will be referring to those critical quality characteristics which are measurable, and if you cannot control their values or say the processes from which these quality characteristics are generated, suppose you lose control on these processes, what will happen, might happen that the entire production process may become very, very expensive. Is it okay? And along with, there is a high chance that you will be producing non-conforming output. It's clear. So these are the two situations you must be able to avoid. Is it okay? To prevent the occurrence such situations. So, you have to be, very selective, and you select the quality characteristics in such a way for control charting, so that this in the critical quality characteristics you must be able to avoid. So, monitoring process variables through control charts implicitly controls product characteristics, because the control, this process is related to a process when I refer to say a particular process, then for which a control chart is to be drawn. So, the control chart is to be drawn or constructed for quality characteristics. This quality characteristic is related to a particular product. So, obviously, directly as well as indirectly, by controlling the process, you are also controlling, okay, the quality of the product. Is it okay? So, this is the context. Now, what are the preliminary decision? Selection of the rational samples. I have already mentioned that the principles of the rational subgrouping. So, you need to maximize the differences between the samples. This is the point to be noted. Minimize differences within the samples. Lots from which samples are chosen should be homogeneous. Is it okay? So, homogeneous, the condition, homogeneity condition you have to arrive at. Related to the sample size, sample sizes are normally between 4 and 10, because we are dealing with the variables data, the information content is more, and that is why what you try to do, that means you may have the smaller sample size. So, between 4 and 10, and usually we say in many cases we will find that the sample size may be restricted to 5. It is quite common in industry to have sample sizes of 4 or 5. Okay. What are the preliminary decisions? That means you have to take a decisions on the frequency of the sampling. That means the number of samples, okay, for construction of the control chart. So, what could be the number of samples to be drawn from the process? The sampling frequency depends on the cost of obtaining information compared to the cost of non-detecting a non-conforming item. So, this point is to be noted, in fact. Is it okay? That means there is a cost for collecting the information. Is it okay? There is also a cost, suppose you do not collect this information. So, obviously, we are assuming that the cost of non-detecting a non-conforming item is significantly more than the cost of obtaining information. Getting my point? So, this is the condition, or this is the conditions you have in your say in your process, and that is why you feel like collecting data. Is it clear? So, this is a very important point I have highlighted. Choice of measuring instrument, this is very, very important. That means while you select a particular measuring instrument, you make sure that it has the right kind of say the accuracy, then the precision, as well as the resolutions or the sensitivity, and then you have to design a data recording form. So, the control charts for the mean and range, that means the mean is notation is x bar and the range notation is r. So, what you have to do, that means in the step 1 what you using a pre-selected sampling scheme and a sample size. Is it okay? Record measurements of the selected quality characteristic on the appropriate forms. Is it okay? So, this is step 1. In the step 2, what you do, that means for each sample calculate the sample mean and the range using the following formulas. So, x bar you calculate, is it okay? For say x bar is the overall say it's a sample mean, that is xi values are there. So, the sample size is n. So, this is x bar, that means the sample mean, and what is r? R is basically in a particular sample, what is the maximum value, what is the minimum value. So, why I have mentioned that xi represents the ith observation, n is the sample size, x max is the largest observation, and x mean is the smallest observation. Then what you do, that means you have drawn g number of samples, that is your sampling frequency. So, when you consider all these g number of samples, you calculate the mean of the means, okay, mean of the means, that is x double bar. So, obviously you have for the ith sample xi bar, and when you consider all these the g number of such sample means and you take their average, obviously you get x double bar, what is the mean of the means. Okay, and similarly for each sample you calculate Ri, that is the range, and we consider the g number of samples and you get R bar. Okay, so that is the measure of process control, process say the variability. Now, what we will assume initially that for the 3 sigma control limits for the x bar chart, you have this general formulation, that is x double bar plus minus 3 times sigma x bar. Is it okay? Now, rather than computing sigma x bar from the raw data, we can use the relationships between the process standard deviation sigma. This is an alternative way and it is an easier way to calculate the sigma x bar, the standard deviation of the individual items, that is sigma x bar, and the mean of the ranges, that is R bar. So, when sampling from a population that is normally distributed, the distribution of the statistic, we have these statistics, that is the relative range. This is relative range is defined as R divided by sigma. Now, what the researchers have found, that this if you consider these statistics and its distribution, so you will find that the mean of W is represented is dependent on the sample size. So, also the standard deviation also so the depends on the R bar by D2. Is it okay? So, obviously for this statistic, so you have the corresponding mean value and the corresponding standard deviation value. So, the mean value mean is denoted as D2, which is a function of sample size, and similarly the standard deviation is denoted by D3, which is which is also a function of the sample size. Now, we have these manipulations, that means control limits for the x bar chart is upper control limit for x bar and lower control limit for x bar is basically this is sigma had by root n. Now, this sigma is basically R bar by D2. This is sigma upon root n, that is sigma x bar, and the sigma estimate of sigma is R bar by D2. Is it okay? And so ultimately this one, that means 3 divided by root n D2 is we have this notation, that is capital A2. So, upper control limit and the lower control limit. So, these two limits are given as x double bar plus minus A2 R bar. Is it okay? Where A2 is 3 upon root over n D2. So, just one assumptions we have here when you use this particular the formulations, that means we are assuming that the control limits are at plus minus 3 sigma limits. Okay. So, similarly for the R chart, what you do, that means upper control limit and lower control limit for R chart is given by R bar plus minus 3 sigma sigma R, and then with this particular the manipulations, what you have to do, what mention, that is sigma R bar by D2, that means D3, that means D4 R bar, and this is D4 R bar and D3 R bar. So, where D4 is 1 plus 3 into D3 by D2 and D3 is maximum 0, 0 and 1 minus 3 D3 minus D2. That means, if it is negative, that means convert it into 0. So, equation, so this equation is the working equation for calculating the control limits. Okay. So, what you try to do, that means for if you want, there are certain steps in constructing the control chart. So the third step we have already covered. Now we go to the fourth step, to determine whether the points are in statistical control. If not, investigate the special causes associated with the out of control points. Suppose you start with 30 the points, so all these 30 points will be plotted. Is it okay? After you determine the upper control limit and the lower control limit, and check whether all these points are plotted within the control limits or not. An R chart is usually analyzed before X bar chart to determine out of control situation, and then delete the out of control points obviously, and for which remedial actions have been taken, and then you go for the final control chart like we follow for the P control chart. So the same procedures you have to follow. Is it okay? So first you determine the preliminary control limits, and then from the preliminary control limits you go for the final control limits, and then you take actions for implementing control chart. Is it okay? So this is the thing. Now what you try to do, that means there are two things very important for controlling the process with the help of control chart. The first one is you try to control the variability in the process. Is it okay? And this is it's a very important assignment as related to any process. So for that you go for using the R chart, and if you are successful in controlling the variability, then at the next stage you go for say using the X bar chart, so that mean of the process also can be controlled. Is it okay? So now that means essentially you first you have to give importance to the variability. If the the variability of the process is related to the design of the process, the functioning of the process, functioning of the internal components of the process. So that is a challenging assignment, and usually the process engineer takes the remedial steps or the preventive measures to control this variability based on your interpretation of the control charts. Okay, so that is point number one. And point number two, that usually but the controlling mean is not that difficult, and usually you will find that the workers while they process certain items on a process, so they are always trying to control the process parameters, even if it is an automated systems or the semi-automated system. So what actually they are trying to control? That means they're controlling the process the parameters. Essentially they are trying to control the process mean. So with this the introductory lecture, so I have highlighted certain important issues related to control charting for the variables. Okay. So in the next phase or the next lecture sessions, I will be discussing the other types of the control charts under variables category.